Welcome everybody, and thanks for joining us today, and welcome to day 3 of Innovator Island, where we'll be building a serverless web application for a theme park. Everything today is recorded, and you'll receive links to these videos after the week is finished. So my name is James Bezic, and I am a developer advocate for the AWS Serverless team. I'm a self-confessed serverless geek. I've been building serverless applications for a few years now, and before this, working at AWS, I was a software developer for a long time and also a product manager for a long time. Previously, I worked for a number of different startups and also larger companies like USA and Rackspace. So I have lots of interests, including theme parks, which is how we ended up building this workshop. Most importantly, on this slide, if you see my email address and my Twitter account, if you have any questions at all, please just drop me a line after the workshop and I'll do my best to help. So today is day 3, so we're halfway there. Congratulations on making it this far. On day 1, we set up Cloud9, the IDE environment, and we also deployed the back end and the front end of the applications, deploying the front end with Amplify Console to a public URL. On day 2, we integrated real-time ride times into the front-end application using IoT Core. Now, over the course of these few days, the goal is really to learn how to use a range of different AWS services to build a real-time web application for your business use cases. All of the code in this week is provided for you, so you don't need to write any actual code to solve the problems. We also have a team of serverless experts on hand. Actually, the whole DA team for serverless is here to answer in your Q&A. So please write any questions you have in the Q&A, and we'll do our best to answer them. Today in day 3, we'll be focusing completely on module 3 of the repo. You'll see the entire agenda of things that we'll be covering on the bit.ly link on the screen. But today we've got 3 topics we want to cover. The first is chromakey in image compositing. So the front-end application allows users to upload selfies. And typically these photos will contain a picture of a person against a green screen backdrop. We want to build a pipeline of several Lambda functions to process this photo. So first, chromakey is the process of taking green, or really any color you choose, from a background of a photo. It's a common technique used in the movie industry and TV. Secondly, we'll look at compositing. We want to take the masked image with the transparency from the first step and then composite other layers of pre-existing images into the photos. Now, for services and architecture today, Lambda API and API Gateway and S3 are really the main tools that we'll be looking at. For the chromakey process, we'll be looking at OpenCV, which is a Python library for chromakey manipulation, and also GIMP, which is a NPM package for compositing images, which is a Node package. What's interesting about this is we're going to be using 2 different runtimes in one application, and you can see a little bit later why that's a good thing in some serverless applications. Most of the day, we'll be talking about the code, going through the workshop, and having various discussions. Now for today, I recommend that you follow along with my demo and run the module yourself after the fact, because I'll be stopping lots of different places just to call out various pieces of code to tell you what they're doing. So just a few prerequisites to keep in mind. Firstly, you need an AWS account. If you don't have one, sign up at aws.amazon.com. Next, please use one of the supported regions shown both in the GitHub repo and on the screen here. We've tested the workshop in these regions currently, so please stick to using one of those. Hopefully we'll have more regions coming online soon. Once you select a region, also don't change the region, or make sure when you switch between services, you're staying in the same region. Now, cost is important. So this workshop is really completely free. We're not charging anything for you attending these 5 days, but you might find running this workshop incurs some small charges. Now, for most people, lots of this will be covered by free tier, but it's possible you will incur some charges. We have added a new cleanup section to the repo that shows you how to decommission all the services and take everything down, which I'm going to go through in detail on day 5. But if you want to leave early or you don't want to continue, please don't forget to run through the cleanup just to make sure you don't incur any additional charges. To take part in today's activities, you will need a laptop or a desktop computer, not a tablet. If you have a tablet, I suggest just watching the video for today and then going through the workshop once you have access to a desktop or a laptop computer. Now, also, please use Chrome or Firefox browsers because we use Cloud9 IDE extensively. We found that it works better with those browsers in terms of compatibility. We'll be using quite a few different services today, including Lambda, API Gateway, DynamoDB, and a few others. So existing familiarity with the AWS Management Console is helpful, but it's not essential. Everything we're doing in this workshop continues from previous days, so we'll be building on all the infrastructure from days 1 and 2. And remember, our goal is to help you complete the workshop. So if you have any questions along the way, don't forget to submit them in the Q&A pod. So the full agenda is in the bit.ly link in the corner of the screen, but for day 3 today, we want to focus on the photo element of the app. We want our guests in the theme park to take pictures of themselves on the rides. So in this section, we're going to be building a photo processing pipeline. Users will upload images from their phone directly from the web app. And on the back end, we're going to process these images with chromakey and then composite the image Innovator Island overlay and other graphics around the image. So you saw some of this architecture yesterday. Today we're looking at the part that was grayed out yesterday. So the part that's lit up is the part that's going to manage the photo pipeline. So the way this works is the front end uploads an image directly into the upload bucket. When the object arrives there, it triggers a Lambda function that then removes the green background from the photo. When the object is then saved in the processing bucket, that triggers a second Lambda function that composites the image. When the final image is ready, it's put into the final bucket, and that then triggers the final Lambda function, the post-process function, and that updates DynamoDB and notifies the front end using a different topic on IoT Core. Now, normally when we're doing these workshops physically, we have a green screen where you can take a picture of yourself and you can try your own image. For today, I've given you a test image we can try, but if you have a green screen at home, you can absolutely try this with your own image too. So after we've completed this section today, your front end will have access to a ride processing photo for our guests. Let's just dig a little bit deeper into exactly what this entails. So in the first step of this, the front end is going to call an API Gateway endpoint. This will then invoke a Lambda function and request a pre-signed URL from S3. In the second step, the front end then uses that pre-signed URL to upload the image directly to the upload bucket. Now this is really important because there's no API gateway or other proxy in between. I'll come back to this a little bit later, but essentially there's a direct connection between your client application and the S3 upload bucket. And then once it reaches the upload bucket, then follows this chain of Lambda functions we talked about earlier. So to show you graphically what this is going to look like, we're going to take a test image of a typical theme park tourist. So this is the person with a green background. This gets uploaded to the upload bucket. And after the processing has been triggered, after the chroma key process is complete, you'll see that creates the same image but without the green background. That gets put into the processing bucket. Next, that then triggers the compositing Lambda function, which takes these graphics assets. It takes a background and a frame. The background will be put behind the person, and the frame will be put in front. Finally, after compositing, that creates this final image, which is put into the final bucket. So let's just talk about the S3 upload process quickly before we go any further, because this is really something that's very powerful if you're a mobile or web developer. And I meet lots of developers who are not aware that you can do this. So it's ideal for any application where you have media or file uploads from a device. And the way you set it up is on the back end, you need an S3 bucket with a CORS configuration. Now, I know CORS is often difficult for many front-end developers because it crops up in many different places. And S3 also has a CORS configuration. So the policy shown on the screen, which you can find in the code for the theme park, sets up the bucket so that we can do these sorts of uploads. Now, the allowed origin in this case is star, meaning anywhere, which I'd only recommend for dev or testing. And in production, you'd want to use a locked down URL. But don't forget to create your CORS setting to the bucket. The second step is to create a Lambda function and make sure that it has an IAM policy with put object capability. And the reason for this is when the Lambda function makes the request for the pre-signed URL, it needs to have the ability to put objects into that bucket. Otherwise, it will fail. The pre-signed URL won't have the permissions to upload the object as needed. On the front end, what you then do is a two-step process. First, you call API Gateway to request this pre-signed URL. And the second part is you take this pre-signed URL and upload your binary data directly to that location, so it goes straight to S3. I'll be walking you through this in the code a little bit later, but I wanted to break down exactly what's involved here. So before we actually get into today's activities, here's an interesting thing that happened. We had an NPM package called UUID that has a breaking change. And so if you deployed the backend code on Monday, you'll need to make a modification for your code in order to continue using this without the code failing. If you deployed after Monday, don't worry about it. I made the code change on Monday to make sure everything works. So this is a good opportunity to show you how you update a function in a SAM stack after you already deployed it. So what I'm going to do now is I'm going to demo the broken code to you so you can see what the problem is. Then I'll update the code in the function to make it work. I'll redeploy that new function and test that function to show you how it's working. And we'll do all this before we start off with the main parts that we have to do today. So first of all, I'm going to log into my AWS console as before. So just make sure you're logged in if you're following along. And I'm also going to log into Cloud9, which I can do from the services menu, just going to Cloud9 here. It will remember any instances you have running from yesterday, so you just click Open IDE. I already did this earlier, so my one is already running here. So what I want to show you is actually in the Lambda console. If we switch to Lambda, I'm going to look at this S3 uploader function. This was deployed automatically on Monday as part of that backend build that we did. Now, if I test this function, what you'll see is it errors out. It shows you this error saying it cannot find the module UUID version 4. So what we need to do is go into the code in Cloud9. If I go into app deploy, and I'll look at SAM app and get upload URL. In here, in app.js, there is a line of code that's broken. It's this one here. So I'm going to comment out this code and put in the code that does work. And I'll save this. Now this code is now the code you will find in the GitHub repo. So if you don't know where to find the code, it's currently there. And you can do a diff on this file to see where the new code and the old code compares. So with that new code in place, what we then do is just run the instructions from yesterday in the module 1, where first we're going to cd into this directory, go to the app deploy SAM app part of this, and we see our template.yaml. Now we've already deployed this template, but we want to deploy it with this change. So first I'm going to do a SAM build. This runs the package.json file and installs any node modules that are needed. Next, I run the SAM package command. This takes our template file and packages it up and uploads it to the deployment S3 bucket. And finally, I then want to deploy this. Now, these are the same steps we followed in Module 1 on Monday. So it simply follows this process of SAM build, package, deploy. And these are the 3 steps you always follow if you want to make changes to a Lambda function. Now on Monday when we deployed this backend, it took a while because nothing had been deployed before. So what you found was it had to build absolutely everything that was in the stack. Today it'll be much faster because what's happening is that CloudFormation is smart enough to know only one piece, one function changed. So it'll only deploy the affected parts of the stack that have changed. So this actually takes place very quickly. So that's now been deployed. So to follow through that again, because I know that was very fast, essentially I've got a code change that happened in the module 1. And I want to implement that in this because I already deployed this on Monday. So I've gone through and I've made that change to the app.js file in the get upload URL directory. And I've just switched out this code and redeployed the stack using SAM build, SAM package, and SAM deploy, the same instructions you'll find in module 1. If you're deploying module 1 from now, don't worry about any of this because the code has been updated and everything's now working. But obviously, sometimes things change in NPM packages, and so we have to adjust accordingly. Let me just show you now, if I go back to that function that was previously broken, what you'll see here, if I test again, is that it now works because the module has now been loaded successfully and everything is fine. Okay, so with that being said, let's start with today's main activities. So I'll just go to our instructions, which are at bit.ly/innovator island. This is the same URL we've been using all week. So this week, I'll just make these instructions a bit bigger for everybody. We're going to do Module 3 today, which is the Photos section. So the intro to this explains some of the things that we talked about in terms of how these Lambda functions are uploading things to buckets, and the buckets trigger subsequent Lambda functions. So the first thing we want to do is set up the environment variables. So what we're going to do here, I'll just paste these in. The reason we have to do this is that because I restarted my Cloud9 terminal a day after, any environment variables are forgotten, so I just put this in here to refresh those variables. If you're doing this workshop in one sitting, you don't need to refresh the variables. So there are 3 stages to this particular section. The first is to create the chromakey Lambda functions. Let's start there. So in this section, we're going to be using an OpenCV library, a Python library that's going to produce the chroma-key output for us. So this is going to use Lambda Layers. So the OpenCV library has to be compiled to the target operating system, and I've already done this for this workshop, but essentially we're compiling against Python 3.6 for the Lambda function. So let's go to the step-by-step instructions. First thing first, in the console, we're going to go to the Lambda console, and then click on create function and call the function theme park photos chroma key. So I'll go to my Lambda console from here. I'll just click on functions. This is create function. So I'm calling this theme park photos chroma key. Now the most important part of this is that we have to select Python 3.6 as the runtime, not 3.8 or 3.7. So we have to make sure we select the right version here, so Python 3.6. Further down, we want to use an existing role in the IAM roles, and then select the theme park Lambda role we've been using for previous Lambda functions. So I'll open up this, use an existing role, and we're selecting theme park Lambda role. And now we'll create the function. Okay, great. So we've now got our empty function. So the first thing to do here is to select add trigger. And what we're going to do is select S3 as our trigger. And we're going to choose this upload bucket as the trigger for this function. Now there's 3 buckets that were created as part of the deployment on Monday. So upload is the first bucket. So we'll go to up here, open the designer. I'll select add trigger, then S3. And then we'll select this upload bucket. All the other settings we can leave the same. I'll just select add. Oh, it looks like we might already have a Lambda function I created earlier. Let me double check that's not the case. So this can happen sometimes when you have an S3 bucket that has multiple Lambda functions that are subscribing to the same bucket. So let's take a look if that's the case. I'll open the upload bucket. And from here, I'm going to find notifications. I don't see any there. Let me just find that for you. Oh, they're down here. Okay, I'm clicking on events. There's an existing Lambda function that already I used earlier, so I'm going to remove this and then save. Okay, so now we go back to the Lambda function. Our theme park photos chroma key. And I'll follow that step again where I just add the S3 bucket and connect it to the upload bucket there, and then click add. Okay, so now when anything gets uploaded to that bucket, this will trigger this chromakey Lambda function. So that's step 4. So let's continue on to the next step. In the designer card, okay, so I've got a couple of messages for people that you just got stuck on the original part where I fixed that code that we fixed at the beginning. So let me just step through that quickly. I'll go through that just so you don't get stuck. In the instructions, if we go to the Innovator Island, the bit.ly link for Innovator Island, we're following the 3 commands from here. I'll just scroll down towards the back end. So this is this section here, the number 6 and 7. When you're in the SAM app, you would go to that directory and then run build, package, and deploy after you've made the change to that app.js file. And I'll show you just so you can see the code change that was made. In the repo itself, this is the code change. So you can see this line was the one that was removed, and this is the new line that's been added. So Chris Munns has posted a gist that contains the steps to fix this. So remember just the steps here, and this is only if you deployed the backend on Monday, this will affect you, is you need to open up this app.js file, remove the line of code that is not working anymore, add in this one line of code, save the file, and then run the sam build, sam package, and sam deploy commands that are in this area here from steps 6 and 7 from module 1. So take a look at Chris's gist. That'll indicate what you need to do to make these changes. Okay, so I'll go back to where we were. I'll just close these down just momentarily. Okay, so what we're going to do next, in the designer card, we're going to add the Lambda Layers. So I'm going to open up the function, click on the Layers button, open up the Layers console. So now below this, you can see there's a Layers panel. Next, I want to add a layer. Now, what I've done already is I've set up this OpenCV layer in these different regions for you to use. So you pick the layer that's in your region. I'm in US East 1, North Virginia, so I'll take this layer here. One of the great things about layers is you can build layers and share them publicly or with your own group or different accounts. So this layer is one I've created earlier and I shared with the world, and it just contains this OpenCV library for Python. So I'm going to add this layer, and I want to provision a layer with an ARN, and I paste the ARN, and then click add. And that's all there really is to adding a Lambda layer to a function. It's not very difficult, and it's a great way of sharing libraries, whether particularly large or things that are external to what you're building. So now on step 4, what I want to do is I want to add the code for this function. So we're going to select the Lambda icon to open the code console. And then I'm going to take the code from this location, 3 photos, 1-chroma key app.py. I'm going to copy that to the clipboard and paste it into this Lambda function. So I'll open this there, 1-chroma key app.py. So this piece of Python here basically contains all the information, all the instructions it needs to take the event from S3 and open the object, the image. And then what it does is it uses OpenCV further down here to pull out the green in the background. It's using basic OpenCV commands to do this. And once it's run through all of those commands, it then writes this back out to the next bucket. So we can go through this in more detail, but essentially this is using another library to do all of the hard work. And the Lambda function itself is fairly small. So I'm going to copy this code here and go back to this Lambda function. I've selected this to open the function console. I want to delete everything that's currently there and just paste in this new code. and then I'll check save. Great, so going back to these instructions, what we then need to do is add some environment variables, and we've got 3 environment variables to add here. The output bucket name, this is where the bucket we're going to use to save the resulting file, and then 2 HSV values. These are hue saturation value. They're a bit like RGB, but they give you greater flexibility when you're trying to filter out individual colors from an image. So I'm going to copy these 3 values into my environment variables. So I'll paste the first one, and then the second one, and then finally this one. Now for the HSV values, these are fixed values, so I can just copy these across right now and paste them into this environment variable. Now the output bucket name, I'm going to get this by running this CLI command, so I can look up the name of my bucket, because everybody's bucket names will be different. So if I go back to my CLI, I'll just clear this. Running this command, all this does is it runs an s3ls command, which lists all the buckets. Then I use grep just to filter on this one bucket that I'm interested in. And I can see this is the processing bucket here. So I'm going to copy that to my clipboard. And then I'm going to put that in my environment variable as the output bucket name, and then click on save. Great. So back in the instructions, what we've done now is we've completed section 3. We took these environment variables, we took the bucket name from instruction number 2 and put that into the output bucket name. The result looks a lot like the screenshot, and then we saved those changes. Now there are a couple of settings we also want to change in the execution roles, because this is a very large library. Now by default, Lambda functions have 128 megabytes of RAM. And often when you're using graphics processing, you want more memory than this. Also, the timeout is set to 3 seconds. It should complete within 3 seconds, but we're going to give it a bit more time. So we're going to change the memory to the maximum, 3 gigabytes, and change the timeout to 10 seconds. So I'll switch back to here. Now in the basic settings panel there, I can click on Edit, and I'll change this to 10 seconds, and then I'm just going to give it maximum memory. We tested this earlier. You actually don't need to give it maximum memory. It worked just fine at about 1700 megabytes, but just for the sake of the workshop, I wanted to show you how you can modify the memory on your Lambda function. And you often don't want to check this because the default value might be too small for your use case. So now I'll check save, and that's now, if I scroll down, you'll see that those settings have now taken effect. So now we get to test the function. So let's go into the directory that has the sample photo. So I'll just change directory. And the sample photo we have in here, if I just open this up, you can see it's called green screen test. And in the Cloud9 ID, you'll see the test image that we saw earlier. So first of all, we want to get the name of our upload bucket. So I'll run this in the console. This is the name of our upload bucket. I'm going to use the CLI to copy the file from my local Cloud9 ID into the bucket. Now you could do this using the console. It's just a bit faster using the CLI. So I'll take this command and I'll replace your upload bucket name with the bucket name from the previous step. Just paste that there. That uploads the image. Now, if we go to the processing bucket, that second bucket, we'll have to take a look in there and see if the image has arrived. So I'll go to the S3 console, and you'll see the 3 different theme park buckets we have. So the upload bucket was where we, if I just refresh, uploaded that green screen image. But in the processing bucket, we can see there's now a new file that wasn't there before. So I'm going to download this so you can see it. I'll just open that. And what you can see is there's an image now with the green removed. And I want to show you something with the HSV values. You see in this image, there's some green that hasn't been correctly removed from the image. So let's take a look at that now. If I go back to the chromakey function, those HSV values are flexible. So if we just edit these, and I'll change the upper limit to 90 instead of 70, this gives us, it makes the matching process a bit more generous, finding more shades of green that it needs to remove from the photo. So I'll save that with 90. Now, anytime you make a change to your environment variables, your Lambda functions immediately now got those environment variables. So if I go back to our Cloud9 instance and I do the upload again, I'll just copy that green screen test image to the first bucket again. This will trigger that Lambda function with the new set of HSV values. Now, if I go to the S3 console and look at the processing bucket and I refresh this, you should see the timestamp change. And the new image, if I download this and open this, you'll see that now all of the green has been correctly removed from the image. So when you're doing color matching, you can play with those values, but by using environment variables, we don't need to redeploy all of our code or anything like that. We can make the changes just in the variables. So going back to these instructions, we've now finished this section and we've completed the part where we add can complete the chromakey process. So the next section to go to, we're going to do the compositing. So this is part 2 of module 3. So in this section, we talk about, in the first part, some of the YAML used in the SAM template that builds the Lambda function we're going to use. So I'll show you this SAM template first. So if I go into this compositing subdirectory just here, this is a fairly small SAM template that only contains a function that we want to deploy. And it tells us that this is a function in the resources, and the code is in the Lambda function directory in an app handler. And this is the code that will be run. This is using a package called GIMP, which is an NPM package. And what it's going to do, if I go down to the handler, it's going to load the S3 object that was stored in the processing bucket, and then add those layers that we saw in the deck, which is the background and the foreground graphics that it's pulling down from CloudFront. Once it's composited those images, all it then does is it saves the resulting image into the next S3 bucket. So first of all, let's go back to the instructions. And we'll start here with these step-by-step instructions. I'll change directory into the compositing directory. Okay, I'm going to pause just for a moment here because I see there's a lot of questions, and let's see if there's anything I can answer quickly. So on Lambda Layers, Lambda Layers is a really useful tool for Lambda that lets you package up libraries of code. So you've got 2 different ways, really, of getting code into Lambda functions. The first is when you do your deployment through SAM or Serverless framework or another framework. What happens there is all of your NPM packages or your Python dependencies are being packaged up into a big zip file and uploaded to your Lambda function. The second option is if you use layers, you can separate that out from your code. Now, typically, layers are a good way to bring in libraries that are outside of your project, such as OpenCV in this case, rather than just things that you use on a day-to-day basis. So for libraries I'm using in NPM, like Axios or Vue.js, I leave those in my deployment package. But when I have code libraries that I want to use that are external to what I'm using, I tend to use those in layers. Now, you can build layers in SAM as well. In this workshop, we don't do that just to keep things moving. But in terms of the code you build, you can also use SAM to produce a layer, which can then be consumed by other Lambda functions. So the OpenCV layer, apparently I missed the ARN for one region. So bear with me. After the workshop, we'll make that ARN available in the region, and so you can continue from there. My apologies for that. Okay, so I'm going to also go back a step just to show you the HSV numbers in here. So HSV is a color system, a lot like RGB, but it's hue, saturation, and value. So the way you use this, if you're matching a color like green, in RGB this would be fairly complicated because green has a lot of red and blue components in the photos. You'd have to match against lots of different color sets. HSV makes it much, much simpler to match on processes like chromakey. So in this function, there's a lower and upper bound for an HSV value, and we can simply play with those values to make sure we get the green matching the way we want it. Now, in a real production application, chromakey is complicated because the lighting of the green screen impacts the way the green appears in photos. If you're doing this in production, you want to be able to test this against an environment where you know what the greens look like so you can set the appropriate range of values. Okay, so I'll continue here because we've got a few more things to get to today, but if you have any other questions, we can continue after the next step. So we're going to start this compositing process. So first of all, I'm going to change directory into the second compositing folder there. I'll just clear the display. So we're now in this directory here, to compositing. Now I need to get the name of the final bucket. So again, I'm going to use a CLI command to find out what that is because it varies depending. Each SAM deployment creates a new SAM S3 bucket name. So I'm going to use this command to get the name of the final bucket. So for me, it's this with this code at the end. And now we're going to build and package this SAM deployment with the Lambda function. So I'm going to run the same commands here. So it's be SAM build, which again, what that does is it installs any NPM packages that this function needs locally within the Cloud9 IDE. And then SAM package, this takes the template YAML, packages up with the code, and uploads it to our S3 deployment bucket. So this is a fairly small function, so it's pretty fast. And then finally, we just run SAM deploy. This will now deploy the function to our AWS region. So I'll wait here for just a couple of minutes until this has been fully deployed, and I'll answer any more questions. So there's a question, can we see the code in the layer that's being added? Yes, what I'll do is I'll open up a layer. I'll provide a link to the zip file, and I'll put it in the GitHub repo so you can take a look at the OpenCV layer. What it is essentially is it's just a Python layer where I've downloaded the code and packaged it up, but having a look at the zip file will show you the structure of what a layer looks like. Okay, so that now has been deployed for my function. So what we're going to do is this. So we'll go back to the instructions here. The first thing we have to do is add the S3 trigger to this function. So remember, this one is being triggered by that second bucket. So what we'll do is we'll go back to our Lambda console. We want to find the function with a name that begins with this with composite function. So I'll just go back to this. And you'll see we've got this function called composite function. The next step is to add the S3 trigger. So this is similar to the last step. We'll be adding the trigger, selecting S3, and then selecting the processing bucket for the function. So I'll select add trigger, and then S3. In my bucket dropdown, I want to select the processing bucket. And I leave all of these other settings just the same, and then click add. Now, before I do this, it's possible in other applications, if you're only interested in certain file types, or you want to match on a prefix or a suffix of an object, such as only JPEGs, you could do this here. So you just add your suffixes or prefixes in this part. And then Lambda only gets invoked if the objects match those patterns. Okay, so I've got an overlapping trigger again. So this is caused by the fact that the S3 bucket already has a trigger. So it's the same problem as before. What I'm going to do is just go back to the processing bucket, which we've got open here. And I'll click on properties, I'm just going to remove the events that are already connected from testing earlier. So I'll just delete that event there and click Save. The reason for this is you cannot have more than one Lambda function listening to an S3 bucket that has the same prefixes or suffixes. So now when I go to add the trigger again, I've deleted the previous one, that'll work. Okay, so continuing on with this, now we get to test this function. So what we're going to do here is cd into the photos directory. And we'll get the upload bucket name again. I'm going to copy this green screen test into the S3 bucket, just like we did earlier. So I'll paste that command and then put this bucket afterwards. And that's uploaded. Now, if we go to the S3 console in the instructions, what we want to do is look in that final bucket to see if the compositing process was successful. So we'll go into this the final bucket here. And you'll see there's a green screen test JPEG. Now this, if I open it, you'll see this is the final image where it's composited the background graphic, the foreground graphic, and the post chroma-key picture of the person. So the final step of this, we've now completed the part where we've done all the photo manipulation, but the front end that did the upload doesn't know that anything's happened. We need to alert the front end now that this new image is now available. So let's go back to the next step, and this is the post-processing function here. So what we're going to do is create a new Lambda function, and we're going to call it theme park photos post-process, and it's a Node.js 12 function. So I'm just going to copy that in here, and then create a new function. Now we need to use that existing role like we have before, the role called theme park lambda role. So I'll just select that from the permissions dropdown. Let me start typing, it'll match there. And I'll click on create function. You can see those are the things that we added, just as shown in the screenshot. Now this is another function that's triggered by S3. So I'm going to click on add trigger, but this time the trigger will be the final bucket. So I go back to the add trigger option. I'll select S3. And I want this to be triggered by the final bucket. I'll leave all of these the same and then click on add. Great, so now we've completed step 3 there. Next, what we want to do is add the code for this function. So let's find the code in our repo. It's in the 3-process app.js file. So I'll go back to Cloud9 and find this code here. Now this code, it's worth just walking through what this does quickly. So if we go down to the Lambda handler, remember the handler is the first thing that's invoked by Lambda. It receives the event, which is the S3 object. And what it's going to do is then save the information to DynamoDB and publish to IoT. So if you remember how we did this the other day with the IoT topics, this is doing exactly the same thing. It's saving the change to DynamoDB, but also telling IoT as a method of getting the information back to the front end. So we'll copy this code here. And if I scroll down to the code in the Lambda function, I'll get rid of what's there currently and just paste that in. And then click on Save. Now back in the instructions, so we've just copied that across. Step 7 is Save, which we've done that. And we've got 2 environment variables that we want to add. One is IoT data endpoint, because remember it's using an IoT topic, so it needs to know how to talk to that topic. And then the DynamoDB table name. So I'll take these 2 environment variables. I'll scroll down to the environment variables section. I'm going to add 2 variables, so I'll add the first one, IoT data endpoint. And then the second one, DynamoDB table name. So what are these values? So using these instructions, we can get these values. The first is to get the IoT data endpoint using this CLI command, which will run in the Cloud9 console. We've done this one a few times now, so it's the same value as before. I'll copy that into our environment variable. And the second part is the DynamoDB table name, which again we can get from the console if we prefer, but it's just faster to get it through the CLI. So pasting this command, it tells DynamoDB to list all of the tables we have available, and then we just grep for the table for our application. So I'll take the name there and paste that into here, and then we'll save. Okay, so back to what we've done here. So now we've edited those environment variables. Those look like the screenshot. We've saved those changes. The final step in this section is to update the front end. So it needs to know about these changes. So what we need to do is add the upload API gateway endpoint to the front end code. So what we're going to do is just execute this CloudFormation command to get the API gateway endpoint we need. So I'll copy this across, paste that in here, and that is the API gateway endpoint. So I'll copy that to my clipboard. Now, just like before, we want to be able to change the config.js file in our front end. So over here, if I move over to the front end code within the source directory, you'll see the config.js file there. Now, each of these sections is broken out by module. We've already done module 1 and module 2. So module 3, we're just going to paste this API gateway endpoint. And you'll see it's basically the same API gateway URL, except for the path that's being called just there. So you should find once you've done that and you save the file, it looks like the screenshot shown here. Now, as before, anytime we make changes to the front end, we have to then push that to our code commit repos so that alerts amplify about the new build. So let's do that. We'll cd into the front end code. And then we'll commit this change. Remember, with this, you want to make sure the file has been changed. In Cloud9, you get a little circle that appears here if it's not saved. So I'll commit this change, and if all is well, it should say there's one file change. That's the config.js file. And finally, we'll do a git push. This will push all the code changes, just one file in this case, to code commit. Now, if we go to Amplify console, which we saw yesterday, I'll just open this up from the management console, go to Amplify. What we'll see is that it's detected there is a new build that's happening. So without us having to tell Amplify directly, it's got a hook into the code commit repo. So when we did that commit, it's causing the build to happen. So this will just take a couple of minutes. So I'll wait here for everybody to read forward, and I'll take any more questions that we have open. So some questions about the video. So the video will be available, today's video, which is Wednesday, will be available on Friday, and the videos later in this week will all be available by the end of this week. So hopefully in this session I can walk you through what needs to be done in the workshop, and then after this you can go through with the workshop instructions and review with the video to see how the steps flow. So the latest code in the repo, regarding that bug fix I showed you at the very beginning of this, the latest code does have that bug fix included. So if you're actually deploying the front end from today, you don't need to do anything different. You just can deploy all that and everything is managed. The change to the code to account for the NPM module change is only for people who deployed on Monday because you have the old version of the code. But if you deployed after that, don't worry about it. Your code is fine. So in my Amplify console build, you can see now this has been provisioned, and we're now in the build process. One question I have here about removing all of the stacks. Somebody's asked how do we remove the stacks we've deployed. So these are SAM deployments, but under the covers, SAM deployments are really just CloudFormation deployments. So if you go to CloudFormation in your services dropdown, I'll just open it in a new tab. You will see all the different ones we've deployed in the last couple of days, and they have the stack names that you used in the deploy command. So if you want to take one of these down, all you would do is select the deployment and click on delete, and that will delete the stack. If you have anything like objects in S3 buckets, you'll need to delete those first before you delete the stack. But then if you want to redeploy a stack from the beginning, that's how you would do it. Simply delete the stack here, and then rerun your SAM package and deploy commands. So I'll just go back to Amplify Console. And we're still just building here. Well, one question about the IoT topic. This is a good question. So we use IoT Core. We've done this a couple of times now. What you can do, if you go to IoT Core in the Services dropdown, I'll open this in a new window. What you can do from here, if you open up Manage and click on Things, things are like projects. So I have two different projects that are running IoT Core. You should see one called Theme Park Real-Time in your project. Now, if you open this, on the left-hand side, you can select Activity on the left, and then MQTT Client. Now, if you want to see what's going on going through these topics, you can subscribe to the topic in the console. So if you remember the other day, we had this one called Theme Park Rides. If I select Subscribe to Topic, every minute where Theme Park Rides publish new information, you'll see that appear in this window. So it's a very useful debugging tool if you want to be able to watch the traffic going through topics while you're writing applications. I'll leave this open for a minute until the next message comes through, and you'll see that come through there. Let's have a quick look at Amplify Console to see where we are with the build. Looks like we're still in the build process here. Okay, we'll give that just a couple more minutes before proceeding. So once you finish pushing out the changes to the front-end application, it'll open up a new gallery button on the UI. You'll be able to add pictures and see the composited images. And when you upload an image through the front end, you'll notice that the front end gets alerted as soon as the build process is finished. And one of the interesting things about this for web developers is this is a good illustration of how asynchronous workflows can work for you, because the back-end process of processing this image may take a few seconds or some period of time. By running it asynchronously, your front end simply uploads the image and then receives a notification from IoT Core when the workflow is completed. This is a really good way to build highly scalable workflows when you have processes that take several seconds, several minutes, or even several days. So you have things like e-commerce processes that process orders. Instead of using synchronous commands, using an asynchronous flow like this can really make it a much more scalable and robust process, and also improve the notifications for your end users. Okay, so what I want to do, because we're running out of time a little bit, I want to just go back to reviewing what we've done today. I'm sorry we didn't manage to get the Amplify Console piece finished in time. Let me just recap what we've done. So today, this is the photo processing piece, and this lets the users upload images of themselves against a green background from the front-end application directly into an S3 bucket. And then we use our Lambda functions to process the images that have been uploaded. So the thing that I think is most interesting about this is that OpenCV is a Python library and GIMP is a Node library, and both are good tools for this process. So this shows how you can use different runtimes for the task. Now, I want to give you a bonus challenge for tonight, for tomorrow's webinar. So tonight, if you can, take a look at Module 4. This is internationalization of the application, where currently everything's in English. But what this Module 4 lets you do is you use Amazon Translate to translate parts of the strings that are in the application into a variety of different languages. And you can use this as part of your code pipeline process, so you can internationalize the code that appears to users in the front end. So take a look at Module 4. I'll review it quickly tomorrow, but it's a very short section. It shouldn't take you more than 10 or 15 minutes. Now tomorrow, the park goes live, so the doors will open and 50,000 people will arrive. And in tomorrow's session, what we'll be doing is capturing all of the streaming data from the visitors' wristbands to help us answer some business questions. So the park owners want to know which rides are popular, where the guests have visited from, and a range of other questions. So tomorrow we'll be introducing Kinesis Data Firehose and QuickSight and going through all of the analytics of the park. In the meantime, if you have any questions, please feel to reach out to me via email or Twitter on this handle. The email is jbezic@amazon.com. Otherwise, thanks very much for attending. It's a pleasure to talk to you, and I'll see you tomorrow.